This video is over constant rate of change. So before we begin this lesson, let's look at our how do you know our number routine. Cassandra used 2 8/10 gallons of milk for her Nanaimo bar. Her mother said in Canada it would be 10 and 612 hundredths liters of milk. 10 and 612 thousandths liters of milk. Is her mother right? So let's look at our conversion chart. 1 gallon, or each gallon, is approximately 3 and 7,900 liter. So for those who prefer tables, this will be for gallon, and this will be for liters. You could write it the other way around if that is what you prefer. So for 1 gallon is equivalent to 3 and 7,900 liters. So if you have 2 and 8/10 gallons of milk, how many liters of milk would you have? So do you like multiplying between? If so, you will multiply by the scale factor of 2 and 8/10. So 3 and 7,900 times 2 and 8/10. I'm just going to tell you it is 10 and 712 thousandths. However, some of you may prefer multiplying within. How do you turn 1 gallon to 3 and 7,900? You multiply by 3 and 7,900. So 2 and 8/10 times 3 and 7,900 would be 10 and 612 thousand. So let's watch our video. Do you know what movie this is from? Titanic, one of the highest grossing movies of all time. So the Titanic struck an iceberg at 11:40 p.m. on April 12, 1912. This is based on a real event. At 2:40 a.m., it sank. The Titanic held 46,326 gross tons. If the ship filled with water the same for each hour, what was the constant rate of change in gross tons of water per hour? So as you can see, the Titanic was a really large boat. Person, car, bus, you could fit many airplanes inside here. So let's solve this. So it started at 11:40, it sank at 2:40 a.m. How many hours is that? 11:40, 12:40, 1:40, 2:40. That's about 3 hours. So the constant rate of change. So it took 3 hours for it to sink. And it held how many gross tons? 46,326. So I want to know how much is changing in tons of water per hour, each hour for 1 hour. So we need to divide this. So to turn 3 hours to 1 hour, I divide by 3. So what is 46,326? So the constant rate of change, it changed from 2:40 a.m. from 11:40 p.m. to 2:40 a.m., which is 3 hours. It changed. It started with 0 gross tons of water to 46,326 gross tons of water. So if I divide this by 3, it goes in 1 time. How many 3's go in 16? 5 times. 16 minus 15 is 1. I bring down the 3. How many 3's go in 13? 4 times. 13 minus 12 is 1. I bring down the 2. How many 3's go into 12? 4 times. Bring down the 6. How many 3's going 6? 2 times. So that means each hour the Titanic filled with 15,442 gross tons of water per hour. That's what is changing. We're going to skip this. And I do not know why this video does not work. Maybe you're unlimited. Oh, here it is.
It's the old woman who lived in a shoe. Let's go visit her.
Why does she live in a shoe, Jack?
Why not, Kate?
I wish I lived in a shoe.
There was an old woman who lived in a shoe.
She had so many children, she didn't know what to do.
So there was an old woman who lived in a shoe. She had so many children she didn't know what to do. So she decided to hire Peacocks babysitting service. It cost $8 for 2 hours and $20 for 5 hours of babysitting service. The old woman wanted to determine if the cost was related to the number of hours of Peacocks babysitting service. So complete this table. So let's complete this table. We know 2 hours will cost her $8. 5 hours costs her $20. So how could I fill this out? Let's think. If 2 hours it costs $8, if I divide it by 2, each hour must be $4. So 2 hours will be $8. 3 hours will be $12. 4 hours will be $16. And 5 hours will be $20. The cost depends on the number of hours. So the cost depends on the number of hours. So if we turn this table into order paired, if you forgot how to graph ratios, go back to our subsequent past lessons. So it's hours and costs. So hours and cost. So let's label this. So these are the number of hours down here, and these are the cost. So let's look at a table. 1 hour costs her $4. So 1 hour right here costs her $4. 2 hours costs her $8. 3 hours costs her $12. 4 hours costs her $16. 5 hours costs $20. As you can tell, the rate is changing the same amount. So what can you summarize about this graph? What does it mean in word form? Peacock charges a constant rate of blank per blank. How much are they charging per hour? From what I could tell, it seems like $4 for every hour, another $4 for every hour, another $4 for every hour, another $4 per hour. So the constant rate of change it charges is $4 per hour. That is what's happening. If you want to, let's look at our tabular representation, our table. Is it increasing $4 for every hour? It is. Let's look at our graphical representation. Is it going up $4 for every hour? It is. And that is what's happening here. What happens if you cannot see it through the tabular form or the graphical representation form? You can do it a different way. Pick an order pair from the table or from the graph. I'll look at the table. 1, 4, and 2, 8. So 1, 4, and 2, 8. How much does y change? That is this. Remember, in a graph is x comma y. How much is it changing? It started at 4. It went to 8. It changed by 4. How much did the x change? It started at 1 and it became 2, so it changed by 1. So that is called rate of change. Rate of change is a change of y to the change of x. It is written as a ratio. So you find how much y changes, you find how much x change. You probably did that in your head. You looked at this automatically and said, well, let's see. It's changing by 4, the cost. The hours are changing by 1 hour. So it's changing $4 for every 1 hour. You can also look at this. If you look at each order pair, it's changing each by $4 by every hour. So change of y, rate of change is change of y over change of x. So y is changing by 4, x is changing by 1. So it's changing by $4 for every hour. So what happens if it is the same for several quantity? That is called a constant rate of change. If you look at our table, is it changing the same amount at every order pair? It's changing $4 here, changes $4 here, changes $4 here for every hour. So that's why this is a constant rate of change. So no matter how many hours she uses Mrs. Peacock's babysitting service, she will always be charged the same constant rate of change, $4 for every hour. So let's practice some examples here. On July 1st, 2014, Twitter reported the number of tweets sent during various time intervals over the course of one day. If the number of tweets sent is the same for each second of the day, use the data to complete the table and graph. So in 5 seconds, there are 36,815 tweets. In 10 seconds, there's 73,630 tweets. As you can tell, they left off part of this. Using my calculator, let's see. Let's see, from 5 to 10. So every 5 seconds, there are 36,000. So I'm going to add 73,630 to this 10 seconds. So 5 seconds plus 10 seconds is 15 seconds. So 36,815 plus 73,610 would be, let's write that down. Calligraphy. That's 110,445 tweets in 15 seconds. So 25 seconds. How many tweets would that be in 25 seconds? So, well, we know at 20 seconds there are 147,260. If I add 5 seconds to that, or 36,815 tweets, it will equal, oh, cool. Sweet. I don't even have to write it down now. So, all right, so let's think. If at 20 seconds there are 147,260 tweets, plus, and in 10 seconds there are 73,630 tweets, there will be 220,890 tweets in 30 seconds. Let's do 45 seconds. Well, I'm going to add 294. There in 40 seconds, there are 294,520 tweets. I'm going to add that to 5 more seconds, so because every 5 seconds, 36,815 plus 331,335 tweets. In 50 seconds, let's see, in 40 seconds, there are 294,520 tweets. I'm going to add that to 10 seconds, which is 73,630. Let's do it again. 40 seconds, 294,520 plus, in 10 seconds, there are 73,630. So that means in 50 seconds, there's 368,150. Now let's graph this. So in 5 seconds, there's about, let's see, the scale is 25,000. So in 5 seconds, there are about 36, so that goes somewhere right here. In 10 seconds, it's about 73,000, 25, 50, 75, so somewhere right here. In 15 seconds, there are 110,000 tweets, so that'd be a little above 100,000. In 20 seconds, there's 147,000 tweets. That's close to 150,000. Ooh, have you noticed that our table is a constant rate? It is changing the same amount for every 5 seconds. The same rate. So 25 seconds is 184,000. That would be somewhere right here. In 30 seconds, about 220,000. That would be somewhere right here. In 35 seconds is 257,000. That would be somewhere right here. In 40 seconds, about 294,000. That's about close to 300,000, a little less. In 45 seconds is 331,000. That would be somewhere right here. In 50 seconds, about 368,000. That would be somewhere right here. And in 55 seconds, about 404,000, close to 400,000, right here. So as you can tell, it is changing by the same amount. The number of tweets is changing the same amount for every 5 seconds. So the question is, how does the number of tweets change with respect to a change in time? From what I can tell, it seems like it is changing every 5 seconds. It is increasing by 36,815 every 5 seconds. Do you agree with that? Let's see. In 5 seconds, 36,815. In 10 seconds, it went up to 73,630, which is an increase of 36,815. So find the constant rate of change for tweets per second. Tweets per second. So how many tweets are per second? So let's see. It changed, so we want to see the change. So that's right. So 73,000. So let's look at it. It's change for tweets per second. So our ratio needs to be over tweet over second. We want to find how many tweets for every second, for each second, for 1 second per second. So it's 73,630 tweets. And that took 10 seconds. How is it changing? In 5 seconds, it was 36,815. So for 10 seconds, it was 73,630 tweets. For 5 seconds, it was 36,815 tweets. So how did this change? If I subtract this, change of y over change of x, that would be 36,815 tweets. And that took 5 seconds. But I want to break this down per second. 1 second. So I could divide or multiply by 1/5 or divide by 5. So what is 36,815 by 5 seconds? Can 5 go in 36? 7 times. 36 minus 35 is 1. I bring down the 8. How many 5s go in 18? 3 times. 18 minus 15 is 3. I bring down the 1. How many 5s go in 31? 6 times. 31 minus 30 is 1. Bring down the 5. Whoops. How many 5 go in 53? So there are 7,363 tweets, TW. I could draw a bird. For every 1 second per second. That's a lot of tweets. So that's what's the rate of changes. At 11 a.m., the water cooler was 30 inches. At 5 p.m., the water cooler was 12 inches. He got mad. He just threw it away. Determine, because it's leaking. Determine the constant rate of change for the water level per hour. So they want you to tell me how is it changing, the water level changing for every hour. Well, first of all, it was 30 inches. And it's now 12 inches. So 12 is minus 30. Because now it's 12 inches. It was 30 inches. How many hours was that? From 5 p.m. to 11 a.m. From 5 p.m. to 11 a.m. 12, 1, 2, 3, 4, 5. That is 6 hours. I want to know how much it changed per hour. Each hour. What is 12 minus 30? For those who forgot how to subtract integers, remember, add the opposite. 12 plus negative 30 is negative 18 inches, and that is 6 hours. How do I break that down to 1 hour? Divide by 6, divide by 6. So, it's changing 3 inches per hour. It's dropping 3 inches per hour. If you did not put this negative, it would be wrong. That's what you're trying to say, that it's increasing 3 inches for every hour. No, but if you read the question correctly, it said it started at 30 inches. Now it's only 12 inches. So it is decreasing. The water cooler is decreasing 3 inches every hour. That is what's happening to this water cooler. So this is constant rate of change. Constant rate of change is change of y to the change of x. It's the relationship of the different changes.